Sector and segment of a circle. Sector of a circle. Look at this given circle divided into two equal parts. How are we going to find if we have the area of the colored part? Let us assume that the radius is r units. So the area of a circle is given by pi r squared, and we multiply it by 1/2. So we have 1/2 of pi r squared. Now if the circle is divided into 4 equal parts, what is now the area of our given colored part? It will be 1/4 of pi r squared. Let us see another part of the circle. What is the area of the colored region? So these colored regions are called sectors. It is like a pizza slice. So the area of a sector is directly proportional to the angle that the arc subtends at the center. In the first case, we have 180 degrees. So we can have 180 degrees divided by 360 degrees multiplied by pi r squared. In the second case, we have 90 degrees. So we have 90 degrees over 360 degrees multiplied by pi r squared. And let's say in the third case, we have 30 degrees. So we can have 30 degrees over 360 degrees multiplied by pi r squared. Generally, if the sector angle is theta, then the area of the sector is theta over 360 degrees multiplied by pi r squared. So again, a sector of a circle is the region bounded by an arc of the circle and the two radii to the endpoints of the arc. And the area of the sector is represented by area of the sector is equal to the theta over 360 degrees multiplied by pi r squared. Example number 1. The radius of the circle is 10 centimeters. If the measure of the arc AB is 60 degrees, what is the area of the sector AOB? To find this, we substitute the values to the given formula. So we have the area of the sector is equal to the theta, which is 60 degrees, over 360 degrees multiplied by pi multiplied by the length of the radius, which is 10 centimeter squared. So 60 degrees over 360 degrees can be simplified as 1/6. And then 10 centimeters squared will be 100 squared centimeters multiplied by pi will be 100 pi squared centimeters. Simplifying these, the area of the sector will be 50 pi over 3 squared centimeters or 52.36 squared centimeters. Example number 2. The area of a 60-degree sector of a circle is 100 square meters. Find the radius of the circle. To find the radius, we use the square root of 360 degrees multiplied by the area of the sector over the theta multiplied by pi. By substitution, we have 360 degrees multiplied by the area of the sector, which is 100 square meters, over the theta, which is 60 degrees, multiplied by pi. Simplifying this, the radius will be equal to 13.82 meters. Segment of a circle. A segment of a circle is the region bounded by an arc and the segment or chord joining its endpoints. So this region, the colored region, is called segment of a circle. In finding the area of the shaded segment, we subtract the area of a triangle from the area of a sector, or we have the area of the segment is equal to the area of the sector minus the area of a triangle. Example number 1. Find the area of the shaded segment if the radius is 10 centimeters and the measure of the angle AOB is 90 degrees. Let us say this is the shaded region. To find this, we find first the area of the sector, given by theta over 360 degrees multiplied by pi r squared. By substitution, we have 90 degrees over 360 degrees multiplied by pi times the length of the radius, which is 10 centimeters, and then get the square. Simplifying this, the area of the sector will be 78.54 square centimeters or 25 pi squared centimeters. Since we are looking for the area of this shaded segment of a circle, and this one will be the area of the sector, we have solved already for the area of the sector, and then we form here a triangle. So we will subtract the area of the sector by the area of the triangle to get the area of this shaded segment. Let us now find the area of the triangle, which is given by 1/2 times base times height. Since the given triangle AOB is a right triangle, so the line segment OA will be the height of the triangle, and the line segment OB will be the base of the triangle. And both line segment OA and OB are radii of the same circle, so they both measure 10 centimeters. By substitution, we have 1/2 times 10 centimeters times 10 centimeters. So the area of the triangle will be 50 squared centimeters. Now to find the area of the segment, this is equal to the area of the sector minus the area of the triangle. So we have solved a while ago that the area of the sector is equal to 78.54 square centimeters minus the area of the triangle, which is 50 squared centimeters. So that would be equal to, the area of the segment is equal to 28.54 squared centimeters. Example number 2. Find the area of the shaded segment if the radius is 10 centimeters and the angle AOB is 60 degrees. Let us say this is the shaded segment. So again, we have the area of the segment is equal to area of the sector minus the area of the triangle. By substitution, we have the theta, which is 60 degrees, over 360 degrees multiplied by pi times the square of the length of the given radius. So we have 10 centimeters then square minus the area of the triangle. So let us say this is 60 degrees. So since this one is 60 degrees, let us say we divide this. So this part will be equal to 30 degrees. So in this case, we form 90-degree angle here with 30 degrees, and this one is 60 degrees. So we can recall the 30, 60, 90 degree triangle. So in that case, the measure of the hypotenuse will be equal to 10 centimeters because the line segment OA is equal to the line segment OB. And the shorter leg, this line segment, which is the shorter leg, which is opposite of the 30-degree angle, will be equal to half of the hypotenuse. So this one will be half of 10 centimeters, which is equal to 5 centimeters. Now for the longer leg, opposite of the 60-degree angle, this one will be equal to the length of the shorter leg multiplied by square root of 3. So that would be equal to 5 square root of 3. So in this case, this line segment will be our height of the triangle. And for the base, since this one is already 5 centimeters and there is another part here, so this will be equal also to 5 centimeters. So the base will be equal to 5 plus 5 is equal to 10 centimeters, and the height of the triangle is equal to 5 square root of 3 centimeters. So therefore, we have 1/2 multiplied by the base, which is 10 centimeters, times the height of the triangle, 5 square root of 3 centimeters. Simplifying this, we'll have 50 over 3 pi squared centimeters minus 25 times the square root of 3 squared centimeters, or it will be equal to 9.06 squared centimeters. So the area of the segment is equal to 9.06 squared centimeters. Another solution. So we can use area of the segment is equal to area of the sector minus 1/2 multiplied by A times B times sine C. By substitution, we have 60 degrees over 360 degrees multiplied by pi times the length of the radius, 10 centimeters, squared, minus 1/2 times, since line segment OB is equal to line segment OA, our A and B are both equal to 10 centimeters. So we have 1/2 times 10 centimeters times 10 centimeters multiplied by sine C. So since the angle is equal to 60 degrees, we use sine 60 degrees. Simplifying that, it will be equal to 50 over 3 pi squared centimeters minus 25 times the square root of 3 squared centimeters, or the area of the segment will be equal to 9.06 squared centimeters.